And the final team will be the science team reporting on their data, attempts at data collection at the hotline.
Hello and welcome to the final capstone presentation. My name is Erin Melly and I'm a senior undergraduate in Columbia College studying economics and concentrating in sustainable development. Here with me today is Sam Goldberg. She's studying sustainable development. There are also 3 other members of our team that have worked on this. They're not here today, but Asma Kabaj, Chisom Onye, and Rebecca Pete. Along with the previous group, we too worked with Nicole DeFeo as a representative of the Highline. Yet, unlike the policy team, our team focused on hands-on data collection to measure the current and potential sustainability practices of the Highline. Today we're going to present the research that we found throughout the semester, and we're going to also provide some recommendations when we looked at similar projects, and we're going to give you a glimpse at our final deliverables. So to begin, let's look at the specific research questions that were brought to us by the client and they developed throughout the semester. First and foremost, the first question was, how can the Highline quantify its environmental benefits in terms of the 3 distinct metrics of stormwater, wind, and temperature? That collection analysis consumed the primary first half of the semester. Then we presented that information and remodeled 2 questions with Nicole after the midterm. First of which is, taking into consideration the design of similar projects, how can the Highline integrate new and innovative sustainability practices? And secondly, how can we translate these environmental metrics that we have calculated into a readable platform that's easily accessible to the public?
So the social and economic team mentioned many different certifications, and one of these is the Landscape Performance Series LAF case studies. So this is a process where research teams will collaborate with the Landscape Architecture Foundation to quantify environmental, economic, and social benefits of different built projects. And this is a process that the Highline is currently undergoing, and these case studies were also the source of inspiration for many of the calculations that we did. The first thing that we wanted to look at was stormwater runoff, which is all of the water that doesn't infiltrate the surface of a given area. And in urban settings, it's a particular problem because there's a higher prevalence of impermeable materials like concrete and asphalt, and a scarcity of vegetation. And particularly in New York, it's a problem because of our combined sewer system, which was mentioned earlier. So in extreme weather events, it's possible for there to be a combined sewer overflow, leading to the release of untreated waste into New York's waterways. But projects like the Highline, green space projects like this, can help to mitigate this phenomenon by capturing more stormwater. And so the first thing that we sought to do was to compare how the Highline affected the runoff rate compared to its predecessors, a railroad and then an abandoned railroad with overgrowth. And we found that since its original form, the Highline has helped to reduce the runoff rate by more than 20% just by increasing vegetation. Another aspect that we wanted to look into was how specific vegetation on the Highline contributes to stormwater capture. And so for this, and I forgot to mention with the last slide, we did those calculations by replicating the methodology of an LAF case study for Clyde Warren Park in Texas. And it was from this report that we also got the inspiration for these calculations. Using the LAF case study, we obtained a record from our client for all the trees on the Highline, their counts and their diameter breast height, and we used the National Tree Benefit Calculator in order to quantify how much water the 10 most common trees on the Highline annually capture. And the calculations we did, we believe, are an underestimation because there are many more trees on the Highline. But to give you a rough estimate, we calculated that these trees roughly capture 100,000 gallons of water per year. Another aspect that our client asked us to look into was temperature, and particularly the ways that the Highline might be mitigating urban heat island effect. So as I'm sure many of you know, urban heat island refers to the phenomenon whereby urban settings tend to be warmer than the surrounding rural areas as a result of land use changes that decrease vegetation and albedo. In order to tackle this, or just as with the stormwater though, spaces like the Highline can help to attenuate this phenomenon by offering localized evaporative cooling and by raising albedo. And so the way that we tackled this request by our client was by visiting the Highline on 2 separate occasions and taking air and surface temperature readings not only on the Highline but also on 9th Avenue and in Hudson Park. And we did this at every cross street, and then we came up with an average for the 2 days. And so for the surface temperature readings, we took the surface temperature on the pathways. So these were mostly concrete and asphalt. And then we also took the surface temperature readings on the plant beds on the High Line and created a weighted average. And we decided not to include Hudson Park in this final comparison just because we didn't have the vegetation readings. But as you can see from this heat map, the High Line was generally cooler than 9th Avenue at almost every cross street. And we did the same thing for air temperature. And again, we found that the High Line was on average cooler than 9th Avenue and Hudson Park, and we conducted statistical analysis to verify that indeed these results were significant. So this gave us an initial indication that the High Line might be contributing to urban heat island effect mitigation, but unfortunately accounting for confounding factors like differences in elevation and street width, et cetera, it was beyond the scope of this project.
The third and final metric that we looked at was wind. So we had wind measurement tools where on the 2 occasions that we collected the temperature data, we also went to 8 critical wind spots that the client presented to us. These 8 spots are also common event and venue places at the High Line. So there were concerns because the wind was causing disruption in the events. And so we wanted to look at both mitigation and harvesting factors of the wind present at these sites. We presented in terms of mitigation windbreaker plants, and we presented to Nicole where these could be planted. They're already, some windbreaker plants are already integrated into the horticulture of the High Line. What we focus on here is harvesting through wind turbines. If you see here, this is our calculation for how much the High Line expends on how much energy the High Line expends on its lighting system. So to light the walkways, it's nearly 14,000 kilowatt hours per year. And doing research on wind turbines, we found that one 50 kilowatt turbine could power all of the energy needs of the lighted pathways on the High Line. So that was all the information that we presented to Nicole at the midway point of the semester. And then the secondary questions that I presented earlier, we looked into that. And so taking all of these metrics, our LAF report has very formal calculations. So we wanted to create something that the public could understand because community outreach is very important to this green space. And that's how we developed the 2 distinct deliverables.
So as Erin mentioned, at the midterm, our client asked us to compare the High Line's environmental performance with other similar projects. And part of the difficulty with this request was that in many ways the High Line has led the pack in both adaptive reuse and elevated park projects. And for its predecessors, including its inspiration, the Promenade Plantée in Paris, there are rarely environmental metrics published online or ones that are comparable to the calculations that we did for this project. What we were able to piece together, however, was a list of all of the projects that have emerged in the wake of the High Line's success and the ways in which they have sought to mimic the High Line's commitment to environmental sustainability. And in addition to this, we looked at the ways that they've gone further than the High Line, and so in order to make recommendations to our client about different features that they could consider implementing in the future. So for example, there is a project in San Francisco, the Presidio Tunnel Tops, and it's being designed by the same team as the one that did the High Line. And like the High Line, they're doing things like using open jointed concrete planks for their walkways in order to allow for greater infiltration and to rechannel that water into the plant beds. But further than this, they're also building concrete runnels along the pathways to help guide and collect water. And they're also hoping to use gray water from the surrounding buildings, which are all ideas that the High Line could consider implementing, such as by collaborating with Chelsea Market and the Whitney in order to use their gray water.
Another aspect that we had to reanalyze after the midterm was the feasibility of wind turbines. Nicole brought up the point that the space constraints in the design of the High Line don't allow for a 50 kilowatt turbine, even though that's the smallest that they come in to be built there. So we came up with another calculation that we saw replicated in other LAF case studies. And we took the 8 critical wind spots and calculated the average wind speed. And at the 4 spots with the highest average wind speed, we decided that if you could put a small turbine there, that would those 4 spots alone could generate enough energy to power 10% of the energy needed for the lighting fixtures. So while this isn't the entirety that we originally hoped, it's another way that the High Line can further its sustainability practices. And also wind turbines are a visual thing that patrons can see that how the High Line is engaging, because as we said, a lot of the practices that the High Line uses aren't readily noticeable by the public. So this is an easy way for the public to see the High Line engaging in these practices. These are just snapshots of our deliverables. The LAF report has all of the assumptions, references, and calculations, and there's a few others that we didn't present here today. And then the sustainability report also talks about the horticulture, energy in a couple different contexts, and just frames the entire project of the High Line in terms of New York City and other projects. You could take a look at both of those if you'd like. And
So just to close, we wanted to say thank you to our client, Nicole DeFeo, who's not here, but who will receive this presentation tomorrow, our professor, Stuart Gaffin, and our TA, Colette Eustace. This was a really wonderful project, and we learned a lot about data collection and analysis and communicating not only with our client, but also with our teammates. And in general, we learned a lot about the sustainability practices happening on the High Line in New York City and beyond. So thank you.
I wasn't very clear on the use of turbines. Sorry. And you mentioned that the turbines would be on the High Line. Is that what you said?
well, we calculated we just did a basic calculation, back of the envelope calculation, to see how much energy the lighting system uses, and then we saw that a 50 kilowatt turbine could power that energy needed. And then looking at the space constraints of how big a 50 kilowatt turbine is, it's not feasible to put something like that on an elevated surface. So that's why a smaller turbine at the 4 critical spots would generate enough to alleviate 10% of those energy demands.
And do you worry about interference, considering there's a lot of skyscrapers and the wind?
Right, that's why
might
the
not be
smaller
efficient.
scale turbines were looked at as an alternative method, because that's 100% the reason why a 50 kilowatt turbine would not be feasible.
Thank you.
Also on the turbines, did you look at the, for the turbine that you were working with, that's the usual model of the horizontal axis, or did you also look at vertical axis
In terms
turbines?
of how the height needed for a turbine?
Well, I think I've heard that vertical axis turbines are also being looked at for more urban environments as just a better model.
Yeah, so we didn't know. We just knew that one turbine wasn't feasible. Originally, Nicole had presented to us micro turbines because she thought that was an option, but we found that those were mostly fueled by natural gas combustion, and that wasn't a feasible option. So Chisom was actually the one that looked into the details of what turbines would fit. And yeah, I think she found just smaller scale ones that would fit.
How big are these small scale turbines?
I don't. Oh, sorry.
How big are these small scale turbines?
Yeah, I don't.
They're 6 feet.
Oh, 6 feet, right. So yeah, those are doable. I'm not sure how big. I don't remember the dimensions of the 50 kilowatt. I just remember it being too big to power. But we figured that a 6 feet turbine at 4 spots would be a feasible option.
Does that present, I don't know, if a lot of people are walking next to it, underneath it, does that present a danger of sorts?
So we've talked a lot about the turbines, but that was just because originally, wind was one of the things that our client asked about. So we were trying to take wind readings on the High Line. In our final recommendations, we actually pushed them more towards solar, although we weren't able to make those calculations. But we thought that because plant beds are sort of uniquely positioned or they're uniquely suited to house solar panels because of the evaporative cooling. It prevents them from overheating. We said that might be an idea that they should look into in the future, perhaps with the next semester's students. The turbines were something that we were just initially excited by, and so did more research about. But it does seem like there are significant barriers because they would also need to get permission from the city in order to for safety reasons.
Thank you.
Do we have a couple more?
Yes, I was just going to ask you, where are they getting their electricity presently, and are there no suppliers in the city that actually already allow you to buy into a program that is, say, 50 to 85% renewables? I mean, is the only alternative just to put your own turbines or solar panels? Because a lot of regions have programs like that.
Yeah, so the Highline is part of the New York City Parks Association, I guess. So they receive their electricity through the New York City Park system, right? And so the way that they would get out of that is by supplying their own energy. And that was also just a way to cut costs for them. And again, it's part of like this process of presenting sort of visual representation of the Highline sustainability practices. But yeah, there are other options available to them, I'd say.
Kind of related to that. Do you know what the cost implications, even generally, might be of adding the turbines, and would it be a cost-saving measure to implement them?
So I think our final analysis showed that it probably wouldn't be because these turbines are like hundreds of thousands of dollars. But again, we kind of like towards the end, we're saying they don't generate as much electricity as solar panels might, and there are all these other steps that they would need to take to put them in place. So yeah, we asked our client for a record of their all of their utilities and how much it was costing them, but we were unable to obtain that, and so we don't actually have a reference for that. Do we have one more question?
There's one more question?
Regarding temperature readings, I know that probably the research time that this happened was in warmer temperatures, but does your team have any idea of how the temperature variance with the surrounding street environment might vary in wintertime?
So these were taken, like, we took them on two separate occasions to give, and we took one in one direction on the one day and one in the other, averaged those. So they are statistically significant on those days and warmer days, and we can't say we haven't gone in the colder temperatures now, but like, I wouldn't like go and definitively say that this is reducing urban heat island effect. I would say that this is evidence towards that, and like, I think that it probably does, but based on these, you can't, because there was also the factor of shadows from buildings, and those are just things that, like, in this class, in the scope of the time and the data we needed from the Highline, we couldn't calculate, but it's just preliminary evidence suggesting that that is an effect that's being mitigated. And additionally, it's also an effect that could be looked into because the Highline itself is doing its own LAF report, and this isn't a factor that they analyzed. They looked at like carbon sequestration, which is something that we didn't analyze because we knew that was being already analyzed by the Highline. So it's just something that we think is important that they should look into, and additionally something that the public should be aware of because it's a benefit that's being provided.
The other thing with that is actually urban heat island is like most experienced at nighttime, and we were unable to take these readings at night because their daylight hours were longer and the Highline closes, and also it's really busy at night, and we were encouraged to come at times when there are no people there, so we're not interfering with what's going on, and so that way we have like a clear pathway. And so we did have to take these readings like sort of in the morning and afternoon, and so just in the future though, these are things for other teams to consider, because yeah, it would be interesting to see if the same results held at night and also in the wintertime, as you said.
Yeah, I just want to actually add, I think the answer would be in winter, there would be no difference probably at all. I mean, the cooling comes from the plant activity in the summer, evapotranspiring. It is an interesting question, though, when you use what's called white surfaces. There's a claim that maybe we don't want to cool the city off in the winter by using too much high albedo surfaces. So it's a very, I just want to say finally, data collection is very hard. It's a lot of fun. When I started this semester, I thought it'd be great to give instruments and go and collect, and it's a lot of fun to do that, but it's very, very hard for many reasons. The instruments aren't high enough quality generally. I think you saw in the case of the wind, we really, you really needed strong gusts with the instruments we had. So even though we tried, it is a difficult challenge. But one of the last things I just want to say is what struck me with the client in this case was how little they knew about their own project in terms of data collection. And I wanted to actually ask this about maybe the transportation team as well, how much the organization knows. And quite often we see the sustainability projects providing the client with first order information that they themselves don't have. So they know how to investigate further these kinds of really important questions as well. So this was a fascinating array of projects. I think we can all agree on that. Every year, every semester, it's the same fascinating array. So thank you all very much for coming and asking your wonderful questions. And we actually have plenty of time for some refreshments as well. So thanks, and good luck to everyone who's going to give their presentation to their actual client this week.